Hello, this is Russell Hawley coming to you from the Tate Geological Museum in Wyoming, and I'm going to be talking to you today about the Permian period. This is the last period of the Paleozoic era, and it's also the last period before the start of the dinosaur age in the Triassic. So in the Permian, we kind of have the world set, the stage is set for the appearance of dinosaurs. So if you were to look at the world from space, and it was during the Permian period, you might not recognize it as the same planet. If you look at the Cretaceous world from space, you'd say, oh, hey, look, it's the Earth. And then you'd say, oh, wait, India's an island and North America is cut in half by a seaway. There'd be other differences as well, but it would still be recognizable. Not so the Permian. This is what the world looked like during the Permian period. All of the continents were joined together into a single super duper continent, if you will. Does anybody know the name of that supercontinent? Yes, that's right, Pangaea, meaning all Earth. So you could walk all the way from Moscow to Sydney, Australia, without ever once getting your toes wet in salt water during the Permian. Now, what this means is that a large amount of land in the center of this supercontinent was very far away from the ocean and therefore far away from the clouds that form as the sun evaporates the seawater. And so you would have had desert conditions throughout much of this supercontinent, areas the size of continents covered with sand dunes. It would have been a very arid and hostile environment. If you're in a culture that has time travel technology, the Permian would be a great place to send political enemies and prisoners of war. Now, you might ask, how do we know this, that the continents were joined at that time? Well, fossils are one of the things that indicates this for us. This is a little creature called Mesosaurus. This is a cast. There's a genuine Mesosaurus fossil right here. That's about as big as they get. It's a small creature. These are aquatic, but they are non-marine. No one has ever found a Mesosaurus skeleton in the same sediments as, say, sea urchins or starfish or ammonites or other saltwater creatures. These guys were not living in marine environments. And yet, Mesosaurus fossils are found both in South America and in South Africa. So how did a non-marine creature get from one of those land masses to the other? Well, the answer is that back then, the Atlantic Ocean was not there. They were joined together, and these guys could get from one continent to another just by using the river systems. Now, that's the world of the Permian, but how about Wyoming? What was Wyoming like specifically? Well, the geology can give us the answers to that. If you look around in eastern Wyoming, underneath the Chugwater Formation, which dates from the Triassic, once again, the beginning of the dinosaur age, underneath that is the Goose Egg Formation, and that was deposited during the Permian. It's got a lot of red rocks in it. These are iron oxides produced when oxygen combines with iron atoms. Oxide soils usually indicate a hot tropical environment, and they're usually formed in contact with the air. So this part of Wyoming was not under the ocean when those oxides were forming. Instead, it would have been a subaerial environment. Every now and again, the sea level would rise or the elevation of the land would drop, and seawater would transgress and cover eastern Wyoming. And then later on, sea level would drop or the land would rise and the ocean waters would retreat, leaving seas trapped behind. There was very little rainfall, and so these seas would simply evaporate under the hot tropical Permian sun. As they evaporated, they got saltier and saltier, and the gypsum would precipitate out on the bottom and form a gypsum bed. And they would continue to evaporate, and they got saltier and saltier, and the anhydrite would precipitate out and form a bed on top of the gypsum. And then finally, the last of the water would evaporate, and a salt layer, halite, would form on top of that. When you see those minerals, gypsum, anhydrite, and halite, on top of the other in that sequence, that's a sabkha. That is a dying sea sequence. And it shows us that this would have been a dead seabed during the Permian. It would have looked like the salt flats of Eastern California or Utah, the places where they test nuclear weapons and rocket cars. Again, very hostile environment, difficult place for animals to make a living, and perhaps unsurprisingly, very few, if any, fossils are found in the Goose Egg Formation. Now, if you look at the lateral equivalent rocks in western Wyoming, it's a different story. Here, we are looking at limestone, the Park City Formation and the Phosphoria Formation. And limestone indicates what sort of environment? Anybody remember? That's right, a marine environment. So this would have been covered by ocean. And many creatures were living in that ocean. There's fossils found at the Anchor Down locality near Thermopolis. Here's examples of some of them. Many of them are brachiopods, little lowly sea beasts, filter feeders that look kind of like a scallop or a cockle. This one's Hestidia. These are slightly larger ones here, spiriferids. These would have lived lying on the seabed or attached to hard objects by a fleshy stalk called a pedicle. These are bryozoa, moss animals. And nowadays, they're a minor component of the marine fauna. If they became extinct tomorrow, nobody but marine biologists would notice that they were gone. But they were very abundant and reef builders back in Permian times. Those are also found in the Phosphoria. And also lots and lots of these things here that look like petrified poker chips. Does anybody remember what sort of creature left behind fossils that look like petrified poker chips? That's right, crinoids, the sea lilies. So these fossils allow us then to reconstruct what Wyoming would have looked like, at least western Wyoming, would have looked like about 250 million years ago. We've got our bryozoa there. We've got the brachiopods sticking to the rocks and lying in the mud. And here meadows of crinoids looking like underwater flowers. Very different from today.